Like. الآن بدأت الناس تدخل، انتظر بس دقيقتين على أساس الناس تخش وتخش على طول إن شاء الله. Assalamu alaikum. Good evening, everyone. We hope you all are fine and ready for a fully knowledgeable night. Today is the 7th day and the last day of our technical webinar series, Renewable Energy and Power System. Engineer Wael? Okay. You will come, inshallah. Engineer Wael is here. Yes. Okay, we can continue now. We were so lucky to host a great group of speakers through previous days, but today, because it's the last day, we want to make it special. So we host 3 great speakers in an open discussion to cover the following points. First point that we will cover tonight, pursuing postgraduate studies in renewable energy field. Also, we will cover solar panel and inverter standards. Also, we cover the challenges with the solar energy system equipment in Saudi Arabia. Also, we will cover the technical regulation of solar energy in Case A. And last one, we will cover energy storage technologies. So we would like you to prepare your question to our speakers and write it in the comment space, because we will make you also participate in this open discussion after we finish our questions. So let's welcome our speakers. First speaker with us today will be Dr. Mohammed Al Qarni. He is an assistant professor in University of Business and Technology. His PhD in electrical engineer, power and renewable. Welcome, Dr. Mohammed. Dr. Mohammed, your voice is, you make the, yes.
Thank you. It's a pleasure to be here today with you all. And I would like to salute your effort in this series of seminars during the past 2 weeks. Great effort by you and your colleague. And thank you for giving me the time to participate in such an event.
Thank you. It's our pleasure, Doctor. Yeah. Second speaker will be Engineer Wael Al Theyab. He is the Director of Electrical and Electronic Engineer Department in Saudi Standards. Welcome, Engineer Wael.
Welcome, and thank you all for this nice evening to have a nice talk about the renewable energy and the technical regulation of the solar photovoltaic systems.
It's our honor to host you with us today. Thank you, Dr. Wael. Third speaker will be with Dr. Mohamed Rashed. He is a senior technical trainer engineer in Al Fanar company. Welcome, Engineer Mohamed.
Welcome, Engineer Ahmed. Really, it's a big honor, and it's a pleasure to. I'm thankful also for you in such a great series of webinars. It was really fruitful. Not only this session, I have seen all other sessions. Also, it was really full with great information, and it's really was a nice webinars. For all levels of experienced people who would like to go in deep and or catch the trending nowadays for the renewable energies. I'm very happy to participate in such great events with such experts, and I'm really grateful for you. Thank you very much.
Thank you. It's our honor to get you today. Thank you. Yeah, let's start with Dr. Mohammed Al Qarni. Dr. Mohammed, many students are thinking of pursuing their postgraduate studies in the field of renewable energy. First, do you encourage them to go through that? Is it good or bad idea?
Well, when we talk, actually, yes, this question comes to me a lot from students. Sometimes students who they just started their undergraduate and they start already thinking about pursuing their postgraduate in the field of renewable energy, which I see it as a positive and I encourage it. But we should be we should know what we want from ourselves in the future. So do we really need to go that much technical? What are the opportunities for postgraduate in the market here? I would actually encourage doing the postgraduate in just a specific field, but I would also would like to highlight some of the difficulties or some of the obstacles, such as the market. Do we need really a specific specialist person within this field, or sometimes we can cover some of these topics? For example, we're talking about PVs and PVs installation. There are a lot of, for example, short training and courses, which could be very helpful for engineers who are going to be practicing within this area of PV installation and so on. Also, doing a PhD, for example, on one of these fields will actually limit your job opportunities to be more academic than practicing the knowledge of renewable energy in the field. So if you are thinking of doing a master or a PhD especially, yes, you should be considering that you will be more likely in the academia. So if this what's your plan about, yes, I would encourage you.
Yes. Thank you. The second question is, how such a step could do the impact in the future career? And also, yes, can we make the question as two parts? Also, we have many of specialists in renewable energy in KSA, but also we can't see as a job title like renewable energy engineering, or renewable energy engineer, or specialist of renewable energy. Although we have a bunch of engineers have a specialist in renewable energy. Can you tell us why of that?
Yes, I think our market is emerging market through to more renewable energy applications. So we will shortly see these titles as we having more and more projects in applying renewable energy solutions on the grid scale and so on. However, if we look at renewable energy, we are actually we should be looking at the root of this knowledge. So it's combining between mechanical and electrical engineering. So you will need actually the main principles, you either electrical or mechanical engineering. And as a fresh engineer, the main or the principles of this knowledge, I think they will be enough for you at this stage. But in the future, yes, it would be encouraged to, with experience, you might be able to specify what is the specialty or what is the field that you would like to continue your PhD or your master in it. I actually would also comment on this about the program or the postgraduate programs in Saudi Arabia. We have seen many programs now, but they are partially new. So I think the oldest could be 3 or 4 years old, if there is, most of them emerging in the last 2 years. So even at the education or the institution level, they are not yet ready with these programs. So you would see a lot of, if you compare it to the postgraduate programs in other leading university in the United States, for example, or the United Kingdom, you will see many specialized field within this region or this field of study.
Okay, it's nice, but by talking about programs, what can we list? Can you list the programs that we can expect in the future, near future in the KSA, or what others list can programs in the other countries like UK or USA?
I think mainly you will be talking about renewable energy system. There are some programs which combine renewable energy with sustainability, which is very important when we looking at the energy sector. Also, we can see some programs that focus, for example, in very specific topics such as electric vehicle, wind energy, or even solar energy. But again, I wouldn't encourage to be a very specified in, for example, electric vehicle or solar energy, unless there is a job which required you to be very specialized in this area. Otherwise, you will be narrowing your opportunities on the job market, and therefore, yes, any field you will do, you will be studying, it would add value to you, but you should also considering the job market. We don't actually have, for example, manufacturing specialized in this area who are carrying, developing, and improving. And maybe Mr. Mohammed Rashed would be commenting on this about the job opportunities in the market. Do we really need a very specialized person, and what are the percentage of these compared to, for example, if you're saying about electrical or mechanical engineering?
Thank you, Dr. Mohammed. Engineer Wael, can you tell us about the technical regulation for solar energy? Do you have them here in KSA?
Yes, actually, SASU as the standardization, national standardization body here in Saudi Arabia, we have prepared the technical regulation for solar system. Actually, this regulation aims to lay out the essential safety requirement for solar PV systems that generate electricity and their components. And actually, the components, what we're mentioning here is the photovoltaic units and voltage inverters, cables and conductors, and protection devices. All these components are covered by this regulation. This regulation should be fulfilled by the importers and the manufacturer here in Saudi Arabia or even out of Saudi Arabia. And there's a list of standards within the regulation. All the manufacturer and importer should fulfill the requirement of this regulation. So we have a regulation that's give us the frame for let's say the frame for entering these components to Saudi Arabia.
Yes. By talking about the standards, can you tell us what about the standards for solar panels and inverters and other equipment related to solar system?
Yeah, actually, we have a number of standards that's related to photovoltaic systems and the components. We have the let's say the main standard that we have to a national modification, which is the SASU IC 61215 with its series from -1 and even the -1 and -1-2. It covers all the let's say the kinds of solar PV systems, and also we are trying by this standard.
Engineer Wael?
Adapted.
Engineer Wael, your voice is not clear.
Can you hear me?
Yes, it's okay now.
It's okay now?
Yeah, it's okay now.
Yeah. I was just saying we have a list of standard that component of the solar PV systems. All these standards are adapted from the international standard to meet the international requirement and to follow up the new technologies regarding the PV systems and all the components related to the PV systems. So it's a large number of standards. We are even a part of the IC committees and member of a number of groups related to PV systems to follow up the new technology and how we can reflect our needs on the international level even.
Thank you, Engineer Wael. Engineer Mohammed.
Yes.
Yes. Can you tell us about the different technologies of solar energy that's used in electricity production?
Yes, sure. You can understand that the solar systems in general, we are talking about how to convert the energy from the sunlight into an electrical energy, and this could be happen by two ways: either the thermal of the sun or the light itself. We are talking about the photons of the light. If we are going to of the lines, here we are talking about the solar photovoltaic technology. And solar photovoltaic technology widely used, and everyone know it, which is the solar PV modules, also solar PV cells, that everyone know it. And this is by the photons, or using the photons of the sunlight. But we have also another technology.
Am I the only one?
Didn't
listen carefully to Dr. Engineer Mohammed?
Actually cannot.
Yes. Your
My
voice is not
clear.
Yes.
I'm sorry.
Yes, now it's okay. Maybe if the internet was not good, you can close the cam when you start talking to make it better.
Okay, now you can hear me well?
It's clear now. Yeah, it's clear now.
Okay, I'm sorry. I was talking about the solar systems, which is converting the energy from the sunlight to an electrical energy, and the power or the energy coming from the sunlight could be in two forms: either the thermal of the sunlight itself or the photons of the sunlight. If we are talking about the section of the photons of the sunlight, how to utilize this one to be converted into electrical energy, we are talking about the solar photovoltaic technology. And solar photovoltaic technology have two technologies. One of them, which is widely used and everyone know it, which is the solar PV modules, which is converting the sunlight to energy. And we have also another one of technologies which is not widely used because it's expensive, but it's very high efficient. And now they are working on this one, how to with the technology and the advanced technology. Now they are getting some ways of how to utilize this one with a less cost, to be efficient, also to be used. And this technology is called concentrated photovoltaic technology. Concentrated photovoltaic technology is the solar cells or solar modules that we know, but this one has some modification. What does it mean? It means now for the cells, which is a part of the solar PV module, This is not exposed to sunlight directly, but they are using two mirrors. One is called primary mirror and one is called secondary mirror. Here, the primary mirror is getting the most of the sunlight and concentrated or reflected towards the secondary mirror. And the secondary mirror after that is reflecting the sunlight again through an optical rod towards the cell. But here the solar cell is not the normal one that we are using, which is made of silicon, either mono or polycrystalline, but here it's called multi-junction solar cell. And this multi-junction solar cell is not only made from one semiconductor material, but it has a multi-junctions and also is made of more than one semiconductor material. In this case, I'm concentrating most of the sunlight towards this multi-junction solar cell, and you are telling me, okay, this is a way of only concentrated the sunlight towards the solar cell. No, not this only the purpose of this one, but also we have another we can say a fantastic advantage of this one of multi-junction solar cell, that the normal solar cell, when it's exposed to the sunlight, we are gaining the effect of only the light spectrum with a wavelength between 350 up to 1140 nanometer. This is the normal sunlight spectrum that is beneficial for us from the normal solar cells, because we have ultraviolet, we have infrared, we have another waveforms that is not beneficial, or we cannot use them during the normal solar cell. So by multi-junction solar cell, we can get the efficiency, more efficiency, because we can get a wide range of wavelengths. We can get the power from those wavelengths of the sunlight to produce more energy. This is called concentrated photovoltaic technology, and this is also used with solar trackers in order to track the sun all the day, to get also more sunlight to be focused or concentrated on the solar cell itself. And as you know, because we are concentrating the solar light, the heat is going up. So we have here some losses. So in such cases, we have to use a cooling system. If you count what I said now, you can see that this will be expensive one. But if we are talking about the efficiency of such solar cells or such solar modules compared with the normal one, we are talking about the monocrystalline or polycrystalline. Normal one, the efficiency is up to 25% up nowadays. And we are talking about the concentrated solar photovoltaic technology. We are talking about efficiency reached up to 46%. So this is a great technology. Regarding the thermal, we can use the thermal technology also by using something called concentrated solar power, and this is used in NEOM project. We are using a big mirrors. Either it can be tower, it can be we are talking about dish, we are talking about linear mirrors, whatever, to concentrate the sunlight toward this a tubes which is filled with a fluid which will be used later to heat up the water, which will be converted after that to steam, and this steam will use to spin the turbine of the normal generators or the traditional generators. And such a technology, concentrated solar power, CSP, this is used, as I told you, in NEOM project. This one, a great one. They are using a big, we can say, ball available on the sea itself, and by the mirrors, which is reflecting the sunlight, it's heating up the water inside this one. And in this case also, we have a crystalline water without a salt, and we have also this steam which is used to spin the turbine. This is there is another technologies also, but this is the three main technologies which are used widely, or you can say it's a trending now in the market regarding how to use the solar cells or the solar systems or the solar energy to be converted into electrical energy.
Thank you, Engineer Mohammed. Also, we have a question that you mentioned that solar cell is the reason that sunlight can convert to electricity. Can you tell us specifically why? How solar cells work?
Yes,
you know
sure.
about, yes.
Yes, okay. Actually, we know, everyone know that we have the electrical materials, we have conductor, we have insulator, and we have semiconductor. This semiconductor, the semiconductor material is not a conductive material like the conductors, and not insulation as the insulators. It has, we can say, properties between the conductors and the insulators. But we found that these semiconductors, we can convert it to a generator or a conductive material, either by three ways. One of them, which we are using in the solar systems, is exposing this one to radiations, to the photons of the light itself. There's another ways also, which is used as a diodes or something like that, by putting a voltage across this one, or the temperature, affecting the temperature of the semiconductor material. But we are talking about how to expose this material to the sunlight. So we are talking about semiconductor material. We have silicon, we have germanium, we have many, but you know, the silicon is the second, we can say the second element in the earth crust, which is available everywhere from the sand itself. So if we are talking about the silicon itself, and we exposing this silicon material to sunlight, nothing will happen, because the silicon will have only four electrons in its outer shell, and this one will not be enough to produce the electricity from this one. That's why they are using the doped silicon, which is called a true semiconductor. The true semiconductor is a semiconductor doped with another material, and we are using the phosphor. Hello?
Yes, we are with you.
Okay, because my laptop, I don't know what happened, but you can see me and you can hear my voice?
Yes, we can listen and see.
Okay, I'm sorry. So we can use the doped semiconductor by doping the silicon with a boron, which has 3 electrons in its outer shell, and also doping the silicon material with the phosphorus, which has 5 electrons in its outer shell. In this case, we have a negatively charged layer of silicon doped with phosphorus, because we have 5 electrons in the phosphorus.
Engineer Mohammed? It seems that his laptop shut down.
Again?
Yes,
Okay.
Engineer Mohammed? Yes.
I'm sorry,
yes.
but internet is it's full 4G. I don't know what's happening.
It's okay.
Okay, I'm sorry. Okay.
No problem.
So in this case, we have N layer and B layer. N layer silicon, which means the silicon which is doped with phosphorus, and B layer, which is the silicon doped with the boron. Okay, in this case, we are bringing the N layer with the B layer and put them adhesive to each other like that. In this case, what will happen? We will have a fantastic criteria, which is the B-N junction. What does it mean by B-N junction? Here, when we have the N layer and B layer stick to each other, some electrons from the N layer, we can say it will migrate from the N layer to the B layer. Okay, so some electrons, when the electrons migrate from the N layer to the B layer, which has a positive charges, these electrons will leave holes behind it. And also the positive charges, which migrated also to the N layer, also left, we can say that negative charges behind it. So in this case, we have a region which is a space or free space region, which has no free electrons or no free holes. This is called B-N junction. And behind this one, we have some positive charges and the N layer, and downside we have some negative charges and then the B layer. In this case, we have here in this B-N junction, we have a strong electric field which will inhibit more electrons from migrating from the N layer to the B layer or vice versa. Okay, so now what will happen when the sunlight hits these solar panels or the solar cell? We are talking about the solar cell. These photons or the sunlight spectrum wavelengths, with some wavelengths, as I told you, from 350 up to 1140 nanometer, These photons of the sunlight will hit the electrons in the p-n junction, and in this the electrons which is bonded with the positive charge in this one, in this area, which is called depletion region, or we can say the p-n junction. Then the electron will be free, and it will move towards the n junction or n layer, and the positive charges will be towards the b layer. In this case, the electron would like to move to the B layer. How this one could happen? If you're connecting the load or external circuit with a resistance or load, whatever, in this case, the electron will try to move through this external circuit to go back to the B layer. This is how the solar cell is working. And because of this one, you will find always the solar cell will only produce 0.5 or to 0.58 volts only, whatever the size of the solar cell. The solar cell may be small, may be large, I don't care. We are talking about the voltage produced because of movement of electrons and positive charge from the p-n layer towards the external circuit. But based on the size of the solar cell, here we are talking about the current, because the current depends on how much electrons will move through the circuit. So with the big size of solar cell, we have more current. Small size of solar cell, we have less current, but the voltage not based on the size of the solar cell. It's based only on the depletion region or the p-n junction area.
It's clear. Thank you, Engineer Mohammed. Backing to Dr. Mohammed. Doctor, can you tell us about the courses and the professional training? What do you think we should take them if we want to be a specialist in renewable energy?
There are many training courses and postgraduate programs in the area of renewable energy, and as this area becoming more and more interesting for globally, we will see more and more specialized program. As I mentioned earlier, I think courses postgraduate will be talking about renewable energy. We'll be talking about sustainable energy, as well as electric vehicles and energy storage. This area becomes more and more important in this area. On the side of the training, there are many trainings here. If we're talking in Saudi Arabia, we should be considering the technology that we are applying or the project that actually being taking place. So we are focusing more into solar energy by both types or both technologies, as Engineer Mohammed mentioned here, the concentrated and the PV solutions. So I think this now is the main topic or the main area of concentration in renewable energy, as well as wind energy becoming. There are many projects now in the wind energy, but for example, hydropower considered as one of the renewable energy, but we actually we don't rely on such a system in Saudi Arabia. However, there might be in the future consideration for this technology, especially in the energy storage area, having huge dams in the around Saudi Arabia. So I think, yes, we're focusing on courses on PV installations, energy efficiency, which is very important concept when we're talking about renewable energy. Energy efficiency should be considered as well when we're talking about renewable energy. And there are many courses in energy efficiency, energy auditing, which should help into improving the whole system of electricity or the energy in Saudi Arabia.
I mentioned the storage energy storage. Sorry, can you tell us more about energy storage? What is the role of energy storage in the power system network?
Okay, so energy storage actually playing now a vital role into the smart system that we have into as we are integrating more and more renewable energy system. With the use of energy storage, we could be improving or improving the capacity factor or the availability of these resources. So as we know, for example, if we're talking about solar power, we have like 5 to 6 hours of radiation daily to generate the power. And we still need the power along the 24 hours. So batteries or energy storage with all the technologies that we can use become a very important part to improve the availability of this storage to be used with the demand, for example, at night. And this also the same for other renewable energy such as wind turbine. We also, with energy storage, we are improving the network reliability. We are balancing the system by maximizing the utilization. We could also use this storage to peak shaving at peak time. We could be also improving the efficiency as well as improving the security of the network. So power quality as well, we can benefit from energy storage to improving power quality by managing the voltage regulations, the protecting from the swells, flickers, and harmonics. So yes, they become very vital and they become part of all modern grid or all integrated system with renewable as well.
Thank you, Dr. Mohammed. Engineer Wael, how we can make sure that the solar panel or solar system equipment are suitable for KSA, especially in our climate? You know, we have too powerful sunlight and also sometimes dusty climate. So how can we make sure of that? Your mic is off.
Yes.
Yes.
I hope it's clear now.
Yes.
Actually, the technical regulation was prepared for the solar PV systems. We have take that in consideration and how we can make sure all the PV system components are complying with the Saudi standards, which is adopted from the international standard. Actually, the technical regulation requires setting the maximum operation temperature on the solar panels, and some of Saudi standards, as I just said, was modified to be suitable for our climate condition. And to verify that these and other requirements are meeting the Saudi standard, we have adopted a conformity, let's say, scheme, which is the IEC EE certification system. which is related to the IEC organization. If you know the IEC organization, it's the International Electrotechnical Commission, and all these components should be tested and certified as per the IEC EE to make sure that all the components are meeting the Saudi requirement.
Thank you, Engineer Wael. Also, what's the effect of, tell us about the effect of radiation and temperature on the PV output?
Yeah, actually, as I just said, we take that in our consideration, even the effect of heat and the effect of shadow, even on the PV system. And as Engineer Mohammed just explained, that the semiconductor and the material, it will be affected if there is a heat or shadow, and the main problem will be affecting the power output by the shadow. Most of the users, or the one that will install the system, some of them, they didn't take in their consideration the design and the how they install the system, and how they must avoid the shadow and the heat effect on the solar cell. I think I could say shortly the main problem is the power output.
What about the dust? Does it make any difference or not?
Yes, it will make a difference. That's why we have a certain requirement. We have a standard. You need to all the solar cells and the panels should be tested according to that standard, to make sure the solar panel will be stand on on our climate. Let's say we have a lot of dust here.
Yes.
We have experienced 2 days ago. So it should be tested and fulfilling the requirement of our Saudi standard, to make sure it will stand on the real climate.
Yeah. Engineer Mohammed, can you help us if we have like a dust on our solar panel? How can we treat with that? How can we clean it? Or just let it, or what should we do? Yes.
Yes. This could be cleaned, but with a fiber material. You can know small piece of fiber material. This is the best one to be used. Otherwise, don't use another other materials that could make some scratches on the PV module itself. And but also, I can tell you something, because also I have here 2 systems in in our training institute. This is to be used as a practical sessions. I'm using something called spray. This is used the nanotechnology. This spray is I made one you can say a trial, or you can say one experiment on the production of the solar panels that we have. I have 2 systems, 3 kilowatt and 3 kilowatt. And it gives me more efficiency. How this one is used? This one just spray, and this spray you can use over the PV modules. What the benefit of this spray? With the dust accumulated on the solar module, first one, if you are talking about the summer season, you can clean it with the fiber material. During the winter season, if rains full of the solar PV modules, instead of using this fiber material to be cleaned by yourself, this nano material, which will be coated over the PV module, this one, the water drops will not stick to the PV module. It will convert it to drops like that, and it will take the dust and go out, or go down from the PV modules. This one, instead of exposing my PV modules to the clay due to the dust and the water. So this is one way of making a better or efficient PV modules. Otherwise, if we are talking about the normal dust, we are talking about the small fiber material which could be cleaned. This one we are talking about the small scale systems. We are talking about rooftop. But for bigger projects, sure, you have also it's called fiber material also, but it needs more manpower to can clean this one easily. It can only by fiber material, you can use it. You can use water, yes, you can use water also, but it's better to using the fiber material to remove only the dust in such a climate in Saudi Arabia.
It's clear. Engineer Mohammed, by talking about PV modules, we listen always that it's related to STC condition. What does it mean by STC condition, and what are the STC conditions?
Okay, STC condition, it means if we are talking about, this is acronym for a standard test condition. You know what actually Mr. Or Engineer Wael explained that Engineer Wael is related to SASO. SASO is putting some standards. Why these standards? Because everyone in any place, if this material, PV module, any other things related to this standard, so every one of us can use. So we need something, we need standardization for everything. So the PV module can be produced by many vendors, many manufacturers in different area all over the world. Okay, so if this PV module is giving or generating a certain power with a certain voltage, with certain current, with a certain characteristics, whatever these characteristics, this one should be referred to a certain standard all of us should follow. This is called a standard test condition, and this is a laboratory conditions. Laboratory conditions under which all PV modules should be tested all over the world. We are talking. So we can say that the STC condition or the standard test condition is a benchmark for comparing the PV modules, all the PV modules available in the market. Okay, so let us go now for the specification of the PV module. You are telling me this PV module is producing 500 watt, for example, or 100 watt, whatever. Okay, this 100 watt, it means that if I bring this one here in Riyadh or in Dammam or in Jeddah or any place all over the world, this one will give me this amount of power? Sure, no, because this one based on the amount of radiation coming from the sun, the kilowatt per meter square coming from the sunlight. So in this case, I'm telling you that this PV module producing this or generating this amount of power under a test condition or under a radiation of 1000 watt per meter square. This is 1000 watt per meter square. This is called a standard test condition. And we have another one, which is the temperature, because the temperature and the radiation, both of them affecting the, like Engineer Wael explained, this is affecting the production or the generation from the PV module. So we have another standard for the temperature, which is 25 degrees Celsius for the cell temperature. And we have, or talking about the light spectrum, which is 1.5, the air mass is 1.5. These three conditions, all PV modules are tested in the laboratories under these conditions: 1000 watt per meter square, 25 degrees cell temperature, and light spectrum of 1.5, or the air mass is 1.5. We are testing the whole specification of the PV module under these three conditions, which is called standard test condition, to be used as a benchmark for comparing of the different PV modules.
Thank you, Engineer Mohammed. Engineer Wael, can we say that SASO is using the STC condition? So they both their standard depend on STC condition, or they are different?
Yes, yes. All the standards are mentioning the STC condition. It's an international way to identify and to give the standard terms for testing the PV components.
Yes, it's clear. Backing to Dr. Mohammed. Doctor.
Yes.
Yes. What are the main types of energy storage of our system?
Uh, Talking about power system energy storage, we can categorize them into four main types based on the technology that it's used. So we have mechanical, electrochemical, electrical, and thermal. And these are the main major types. And we have, for example, for the mechanical system, we have the flywheel energy storage. We have also the pump hydro storage. For electrical application, we have the super conducting magnet energy storage, SMES, and also we do have the capacitors and supercapacitors as example of electrical storage. For the electrochemical, we'll talk more about the hydrogen storage, which nowadays becoming more and more playing more important role in the energy market. And finally, for the thermal, we have, for example, the molten salt storage, which can store the energy as a thermal energy and then can be reproduced and generate electricity from this storage.
Yes, thank you. Engineer Wael, can you tell us about the service that can SASO give to other normal people? Like if I want to install, for example, an PV system in my home or in my company, can I get some services from SASO or not?
Actually, SASO, the main rule for SASO is setting the standard and the conformity schemes, which is the, as I just say, the IEC EE certification for the PV system components, and we are delivering our services to the importers and the manufacturers. So you need to make sure first the system are let's say are good for you as an investment by going to Shamsi. If you look to the Shamsi, it's from the I will say it in Arabic, هيئة المياه والكهرباء, which is the electricity and water organization. They have Shamsi, www.shamsi.net. You can go to that website. You can calculate and even decide whether this system is good for you or not.
Yes, it's good. Engineer Mohammed?
Yes.
Yes. Can you tell us about the difference between cell efficiency and module efficiency? Is there a difference between them?
Again, sorry, I didn't hear the voice well.
Yes. Can you tell us about the difference between cell efficiency and module efficiency? Is there any difference between them?
Yes, it's a little difference, but we are talking about the solar cell or the module solar cell efficiency or the module efficiency. Here we are talking about the efficiency which is equals to the power output over the power input for a certain area of the solar panels. So if we are talking about a solar cell, single solar cell with a specific area, so when this one is exposed to the sunlight, it will convert part of the sunlight to an electrical energy. But if we are talking about these solar cells, which is we can say that it's making the complete solar panel, or it's connected in series to make one solar PV module. Around 36 PV 36 cells or 60 cells or 72 cells to make one complete PV modules. Here we are talking that the efficiency of this PV module will be less than the efficiency of each cell alone. And if we are talking about 60 cell, the efficiency or the power coming from each cell separately or individually multiplied by the 60 cell will be higher than the efficiency of the 60 cells if all of them are available in one frame only, which is called module efficiency here. Why we are talking about this? Why the module efficiency is less than the solar cell efficiency? Because we are talking about one PV module. We are talking about the physical layout of the PV module. We are talking like yesterday we saw this one, the monocrystalline, the polycrystalline. We can see that the edges of the solar cells, if we are putting all of them beside each other in one PV module, we have we can say large inactive area, which is not made of solar cells. So the same area, we are talking 1 meter by 2 meters. This area is not all of it filled with solar cells, because we have some large inactive area. We are talking about the frame of the PV module. This is also not a solar cell. So the same area is filled of some solar cells, but with some inactive area, some part of the frame. So that's why we are talking about the overall efficiency of the PV module is less than the efficiency of each cell alone. This is first reason. Second one, we are talking about the solar cell. If this solar cell is producing a certain amount of power and we are connecting them in series, how you are connecting them in series? You are connecting them through, we can say, a fine silver bars or whatever. But anyhow, this one is due to connecting in series. We have some losses because of such a connection of the PV modules in series. And this is also will affect the power. We have another power losses because of the series connection of the cells inside the PV module. So this is, we can make recap for this one, that we have solar cell efficiency, and we are talking about the energy produced from single cell with a certain area. But if the cells are connected together in series to compose one PV module, in this case, the efficiency, or we can talk the total power of 60 cell will be less than the total power of a 60 individual cell, because of the large inactive area or the physical layout of the PV module, and also due to the series connection losses from the cells in one PV module. That's it.
Thank you, Engineer Mohammed. Back in Dr. Mohammed. Dr. Mohammed, how can we evaluate select the proper type and size for storage in any system?
Well, actually, before we selecting the type of the storage, we should identify what is the role of the energy storage to be used for this system. As I mentioned earlier, there are many roles that we can use energy storage for. So we might be needing, for example, a large amount of power for a very short time. In this case, we will be using, for example, flywheel technology. But if we would like to use, for example, energy or energy storage for a long time or a longer time, and with a high amount of power, so we'll be looking for another technology. So first, we need to identify what is the need. Then we'll be looking for the solution, and we can categorize all these energy storage as what is the maximum power rating that could hold, as well what is the discharging time. So some storage, for example, have a high amount of power, while the discharging time it's only for a few minutes or even less, just a few seconds. Other solution could give us a high amount of power for a longer discharging time, where we can use this as to supply, for example, homes or cities if we need energy. Also, the max cycle or the lifetime is considered as one of the factors when we comparing different energy storage, as well as the energy density. So can we, for example, store this amount of energy in a very limited space, or do we need a huge space to store this energy? And finally, the efficiency, which play as well an important role in our evaluation for such a system. I'll just give an example. If we are using, for example, pump hydro as energy storage. So this technology actually, the concept of the pumped hydro is that when we having energy and we don't have any demand at this time, we would like to save, or yes, to save this energy. And for example, we need it, for example, let's say we are using a solar power and there is no demand on the daytime, so we will be storing this energy in a pumped storage hydropower. A pumped storage hydropower, actually, the technique is we having a different level of storage. We will having, for example, a small lake or a dam, and we pump the water. So we having energy now, there is no demand. We will be pumping the water into a high energy or a high water storage. And on the time we need this power, we will just release the water, and the water will flow from the high or from the top area or storage to the bottom, and it could run a hydropower engine or turbine to generate electricity. This type of storage actually could be considered as the largest type of storage that can we store much energy, which could be even to a gigawatt amount of power. And this could be enough to generate the electricity for a whole city of 750,000 homes. So this is one of the type that can be used with our renewable energy system, and it has been used for a long time now, more than 50 years or 30 years around the world.
Thank you, Dr. Mohammed. Engineer Wael, can you tell us about the information that can be written in the solar panel?
Yeah, actually, all the components related to the PV system should be fulfilling the requirement of the standard by providing the nameplate with a certain requirement. And we have mentioned that within the regulation, as a minimum, I'll give you just an examples of these information. We have the name of the manufacturer and the model, type of the unit, maximum unit power, voltage for maximum power, and the current at maximum power, the safety class, the class of fire, degree of protection as per the reference standard, operating temperature range, and the maximum system voltage, and short circuit current, and open circuit voltage. This is the minimum of the information that should be provided within the nameplate. And there is another requirement as the type of the component, and should fulfilling the requirement as per the standard. If doesn't fulfilling the requirement, it should be retested again or it will be failed according to that standard.
Thank you, Engineer Wael. Engineer Mohammed, what does it mean by reverse current protection? Can you explain it?
Yes.
Yes,
Okay.
please.
Yes. Okay. If we are talking about the reverse current, this reverse current, you know that the system of the solar PV systems, it's not connected or composed from one PV module or two PV modules. It composed from many PV modules which are connected either in series and in this case it is, and some strings are connected in parallel, and in this case it's called array. In some cases, we are connecting these strings in parallel through one combiner box, or even they are connected directly to the inverter, which is converting the DC energy to the AC energy. If we have more than two strings connected in parallel to compose one array, in this case, we have a problem or we have some problem that we could face in such a short circuit in one or more than one module in one of the strings, short circuit in one or more than one of the PV cells, and sometimes we have a double ground fault on the cables. In such case, all the strings which are connected in parallel, if we are talking about one string, 10 PV modules in series, and we have 3 strings connected in parallel. One string of those strings, if it is exposed to one of the faults that I mentioned, like double ground fault or shadow on one PV module or 2 PV modules, or short circuit on 3 or 4 PV modules, in this case, the open circuit voltage or the maximum power point voltage or whatever, we are talking about the open circuit voltage, let's say about the open circuit voltage, will be different from this PV string or this string, and it will be less than the open circuit voltage of the other strings which is connected in parallel with this string. In this case, we have a different voltages are connected in parallel. So in this case, the other 2 strings will drive the current towards this string. And this is called a reverse current, because instead of the current flowing from the string towards the load, it's now coming from the other 2 strings towards this string which have a short circuit or other problems. If we have only 2 strings, no problem. Why? Because if the current, even the maximum current passes from one string to another one, it will not exceed the short circuit current which could be produced by the PV cells itself or the PV modules. So no any dangerous or anything would happen over these PV modules available in the shaded string or the short-circuited string. But in case if we have more than 2 strings connected in parallel, we have more currents. Like we are talking about 3 strings, so we have 2 strings will drive the current, their currents towards this 3rd string. So we have double the short-circuit current will be drive towards this string which has a problem, and in such case these PV modules will be heated up, and it will have a destruction in the PV modules available in such a string. So in this case, we need something called a series fuse, and this series fuse will be connected with each string in series, and this one will save, or we can protect the string against the reverse current which would happen in the cases like the short circuit on one or PV modules, or short circuit on one or PV cells in the module, or double ground fault, and there is many other reasons for such case, which will make, as I told, the open circuit voltage of this string will be different than the open circuit voltage of the other strings, which will make the reverse current will be driven from driven from the other PV strings towards this string. So this is called a reverse current, and it could be protected by the series fuse, or there is another technologies like the blocking diodes and the string technology. There is other ways of technologies to protect. But if we are talking just only about the reverse current, this is called the reverse current.
Thank you, Engineer Mohammed. Dr. Mohammed, we all know that wind energy is more efficiency than the solar energy, but it's initially costly, right? So if we think about after a few years or after a few time, the difference between costs will be covered by, because it's more efficiency in wind energy. Why it's not using familiar in KSA, even that one?
Well, yes. Actually, when we consider the tariff or the cost of any renewable energy system, we should be also considering the availability of this system, which affects something we call the capacity factor of this source. So, in order to say that we're having that the wind energy is cheaper than a solar energy, we should be evaluating the availability of the wind energy to make sure it is economically valuable to be considered. When we talk, for example, about solar now, actually the cheapest price or the cheapest tariff for solar energy project is here in Saudi Arabia. The recent project in north of Saudi Arabia, it's recorded as the cheapest kilowatt hour tariff around the world. So, because yes, we have availability of this source, we are using technology that could give us this cheap price. So, in Saudi Arabia, for sure, solar PV would be the most economical solution. Wind, there will be some investment in wind energy as well, but considering the region is not in the area of wind along the year, so it might be not the right solution to be investing a lot compared to the solar. However, yes, it will be a part, and it must be a part of the mix or the energy mix in Saudi Arabia. We're seeing some project far in the north in Tabuk and the north area of Saudi Arabia, where there is, yes, some of wind energy. Another point, when we talking about price of wind turbine around the world, we are talking about more on offshore wind turbine. And yes, offshore wind turbine in North Europe, for example, is producing very cheap energy. And we even saw some cases, for example, in Germany, where they pay you to use the energy that comes from the wind energy because it is exceeding the demand at some times of the year. So yes, we need to evaluate the wind turbine and the wind energy, and we need to evaluate that along the year. And based on this calculation, we can then set the price of the produced wind energy from this area or from this region.
Thank you, Dr. Mohammed. Engineer Wael, is the SAS related only to the PV system, or can be have a standards also for other systems?
Yes, actually, we have take all the areas related to the renewable energy in our consideration. We have a technical committees, which is they are concentrating on the wind energy generation, and they have prepared a list of standard related to wind energy generation systems, and they are still working on that. Every years they have a list of standard. It should be reviewed and make sure it will be prepared and adapted by the end of the year. So we have a list of standards related to the wind energy generation systems, but till now we don't have a regulation as a frame to I say as a legal way to monitor the market.
Is there something similar like STC for wind energy or not?
Yes, yes. All standards are. You will find a minimum requirement that should the component should fulfill. So all the standards are based on the standard requirement, and all the components should be tested as per the standard. And also some of the standards are related to the performance measurement of the electricity producing wind turbines, and some of the standards are related to the monitoring and controlling of wind power plant. And I don't have the time to explain the whole list of the standard, but we have a standard related to the product and even for the measurement of wind turbines.
Yes, good. Yeah. Last question, Engineer Wael. What is the peak sun hours?
The peak?
Peak sun hours.
The peak sun hours. Actually, I will reflect that question to Engineer Mohammed. He can help us with that. I'm in charge of standard. I can give you the standard. But if we take it on the real environment, we need support from Engineer Mohammed.
Yes, Engineer Mohammed with us? Yes.
Yes, yes. Thank you, Engineer Wael. Peak sun hours is a very simple expression we are using in our design. If we are talking about the design of our solar system, if we are talking about a real project or a real design, you shouldn't tell your customer or your client that I will make this system for you and you will gain more money and you will get a saving from your electricity bill. Based on what? When you are designing your system, finally you have to calculate the production or the energy production for your system over the months and over the year and over the whole whole project lifetime. The peak sun hours here is an important parameters we are using in our design for calculating the energy production from the system. Peak sun hours, it is we can say the average daily insolation of the sun in units of kilowatt hour per meter square. What does it mean? It means that we know that from starting from the sunrise up to the sunset, the solar radiation, the power coming from the sunlight, is increasing gradually up to its highest value. Then it will again be reduced gradually up to the sunset. So we cannot calculate by this way how much the energy produced from the sunlight, because every hour, we don't say every minute, we can say every hour we have a change in the solar radiation. So to make it easy, we are making average for this curve, which is the solar insolation over the time of the day, and getting a certain period with a fixed amount of radiation of the sun, which is a standard 1000 watt per meter square. So if the curve is going like that, we can say that the sun gives us 1000 watts per meter square for example, 4 hours only during the day. This is an average for the whole radiation during the day. So in this case, we can use this parameter and multiply this one by the power of the PV module. So we are expecting how much the energy this is if you are using this one to calculate it manually, but by using the different softwares like the PV-Syst or PV-Sol or other softwares, we can get data hourly, and these softwares can calculate all this energy production hourly based on our radiation in every day, in every month over the year. But if you are talking about manual calculations for your off-grid or even on-grid systems, we can use such a parameter for which is called peak sun hours, which is the average radiation of the sun during the day, and the measuring unit of this one is kilowatt hour per meter square.
It's clear. Thank you, Engineer Mohammed. Last question. From your experience in the field, what's the opportunity of renewable energy these days? Engineer, to be a renewable energy engineer for these days. Yes.
Okay, great. If we are talking about nowadays, you have like Dr. Mohammed mentioned this one in the beginning of the session, that we have many departments or many, or can say many profession in this one. But nowadays we are talking about a design engineer and we are talking about installation engineer. If we are talking about the field, we are talking about the field. Someone is going to design a system with all aspects, solar PV modules, that tilt is the orientation of the modules, which inverter, how many inverters could be used, the cable sizing, everything in the surge protection devices, the lightning protection, the grounding of the system, and the distribution board, and how this one will be connected with the utility network. This is one part. Another part is the installation engineers, whose mainly will be a mechanical engineer. And this is the one that used in the field. But you have also one engineer in the studies. This is engineering studies. This is a very important one. Why? Because we are talking about a system. This system, when it's connected with the grid or the utility of our country here in Saudi Arabia, we are talking about the solar, which is exposed to the sun. And if we have some shadow, if we have some clouds or something like that, we could have like a power swing in our network or other effects on our power network. So in such case, we should make like a system stability. We should study the effect of this substation, or this amount of energy will be connected to our utility. So we have another profession used for engineering studies of connecting this solar system or this renewable energies, whatever, this renewable energies to the our system. This is the main three professions available nowadays, rather than the research and development, but this is not available right now in our market or in our country here, because this one related to the manufacturers themselves, who's working in the field of manufacturing of the PV modules, manufacturing of the inverters. This is the most important two items in the PV system. So the research and development in such inverters or such PV modules is very important. And now also we are attending also more seminars or webinars with different companies. We can find a hybrid inverter, which is Dr. Mohammed give us a great a speech about the storage systems. So the storage system will not be connected with the normal inverters. It will be connected with the hybrid inverter, not the on-grid. It will be connected with the hybrid inverter, which could be used as a charger control as well to charge the batteries, will be used in our systems. And we have different technologies also in the inverter. So as I told you, we have design, we have installation, we have engineering studies for system stability, and we have also research and development in the manufacturing area. But the most widely used right now is the design and the installation, because it's the trending now in the in all areas all over the world.
Thank you, Engineer Mohammed. We reached to the end of our question. Let's go to the audience question. We have a question here from Saleh Samdani, sorry. It's about two parts. First part is what's the right angle to put the solar panel in the kingdom? Yes.
Okay. Shall I explain in Arabic or in English also?
Yes, in English. Yes.
Okay. If we are talking about the angle, we have two angles for the solar panels or solar PV modules. One is called is the azimuth angle, and one is called the tilting angle. The azimuth angle is the orientation of the PV modules as an angle referred to the north, as we are in the northern hemisphere, Saudi Arabia in the northern hemisphere. So we are talking about the orientation of the PV module towards the south. This is called the azimuth angle. And regarding the tilting angle of the PV module, we are talking about the angle between the PV module and the horizontal plane. So we are we have different angles here. If we are talking about the optimum angle all over the year, sorry. If we are talking about two different systems, if we have fixed system or solar tracker system, if we are talking about fixed system, you can adjust the tilting angle of the PV modules by two ways. Either the optimum angle, it means the best angle to get the best production of energy during the whole year. The optimum angle should equal to the latitude of the location you are talking about. So here in Riyadh, we are talking about latitude of 24 or 23. In this range, it will be the optimum angle. And there is another angle which is called seasonal angle. It means the construction or the structure of the system. We can change the angle or the tilting angle of the PV module during the summer season and the winter season to get the best production during the summer and the best production during the winter. But this one, sure, it will be more costly. So what will be the angle during the summer? You can subtract 15 degree minus 15 degree from the latitude angle of your location. So if we are talking about Riyadh here, 23 minus 15, we are talking about 8 degrees. In this case, you can put it horizontally. This is the best practice. And for the winter season, you can add 15 degree with the latitude angle. So we are talking about around 40 degree or 45 degrees. This is also the best practice. If we are talking about solar trackers, okay, so then the solar trackers, it have a microcontroller which will change the tilting angle all over all the day with the sun to get the best production from the sun. And he's talking about the efficiency of the PV module. The efficiency of the PV module based on many parameters, based on the amount of radiation, based on the temperature of the location, based on the climate, regarding the dust and other things. Does it will differ? Yes, it will differ. We have many projects. Also, Funan have many projects now. If we are talking about Ha'il area, in this area, we have sun radiation reaches up to 1,200 watt per meter square. And in this area, that we have a great radiation, which will get more benefits from the solar PV modules rather than other areas. We have in Gulf, Sakaka, and these areas also, because the temperature is not going too much higher, which will affect the production, which will affect the production of the solar system, because the efficiency of the PV modules with a higher temperatures may be around 80% because of higher temperatures like in Riyadh or central region.
Okay, thank you, Engineer Mohammed. Another question from this question for Engineer Wael. Do you have different standards for different places or location from KSA, or only one standard for whole the kingdom?
Actually, we are trying to cover the component itself, and as a solar panel, let's say, as an inverter, as protection devices, we are trying to test the component as it is. You can take the component as your design, as the Engineer Mohammed just says. you have to look carefully to the design and do your calculation carefully. The component should be fulfilling the requirement, should be suitable and tested to be working in a system in Saudi Arabia, let's say, as for example. We are making sure all the component that will be installed within a system will be standing in a minimum requirement that was tested according to. So it's just a component and systems, and we are planning to issue a new conformity program related to system as a whole system, not just as a component. We are working on that. I don't have the exact time to even give you more information about when we are going to announce the beginning of this program, which is a certification for the system as a system and not as a component.
Thank you.
If I give you a name of that, which is the ICRE, if you can just search on that, it's an international program.
Thank you, Engineer Wael. Dr. Mohammed, there is a question here told us how to choose energy storage based on what? From Brother Ali.
As I mentioned earlier, so it depends on your system. When you design your system, you should be justify your needs of storage, the size of the storage, and this size means the amount of power and how many hours do you want this storage to be operating for. So the first step you have to calculate the needed energy, and then you will start considering the solution. Some solutions, for example, the pump water solution, it needs a specific geographical regions to apply such a system. So this is another condition. What is the availability of this source? Nowadays, we're seeing the lithium ion as energy storage is becoming very vital and emerging for application such as electric vehicle as well as for power systems. We can see a huge energy storage consists of lithium ion built by Tesla, and that could be producing energy for more than 20,000 houses for about 4 hours. So this solution now is changing the game, and it will give a new opportunities to more installation or more solutions of renewable energy around the world.
Thank you, Dr. Mohammed. Here's a question. What is the effect of cleaning the PV panels by the water for Engineer Mohammed?
Yes, nothing. There is no bad effect, no problem for this one, even because also we have the junction box of the PV module according to the SASO standard also, because it's reflected to IEC, and this IB for such PV modules is IB 67 or 68. So nothing would happen for the PV module, and there is no effect up to now. This is what I know, but I will also go read for this one. If I found anything, sure I will share the new information with Mr. Ziad. No problem for me.
Thank you. Here's a question again from Mr. Ziad. He also said, what is the fixed value of average cost per watt that make us start thinking to install a PV system, and normally the average for buyback value?
Okay. Look, Mr. Ziad, this is from the practice. We are talking about 4,000 riyal per kilowatt. And sure, when we are talking about system of 10 kilowatts, is different from system of 50 kilowatt, because every time you are expanding your system, the cost for each kilowatt will be reduced. The cost of the project will be increased, but the cost for each kilowatt will be reduced. But average, we are talking about 4,000 riyal for 1 kilowatt. And the payback period would be, this is a very important issue. Mr. Engineer Wael talk about this one, Shamsi. Why Shamsi, why Skiko did, or Saudi Electricity Company and ICRA, Electricity and Cogeneration Authority, they do Shamsi website, because we have some people who are going to the clients and say that we will make one system for you and you will get your money back after 2 years only or 3 years only. That's why they're making Shamsi for you, so you can go there, choose your location, and check the power that you would like. It will give you the cost and it will give you the payback period. And sure, I'm telling you, you will not get your money back in less than, up to now, we are talking up to now, the minimum is 5 years. You will not get your money back before 5 years, based on the current situation or current prices. But I'm sure if tomorrow Saudi Arabia said that the tariff for the kilowatt hour for your residential or commercial is increased up to this value, sure, the payback period will be less, because this one based on the capital cost against the running cost. You are making one substation or one rooftop system for yourself, and this system is giving you the energy instead of utilizing the energy from the utility. But so in this case, you are multiplying the kilowatt hour by the same tariff that you are paying for Saudi Electricity Company. So if Saudi Electricity Company increase the tariff, in this case, the amount of energy that you are producing, the cost of this one, or the benefit of this one will be also increased, so the payback period will be reduced. So based on now, you cannot get your money back before 5 years. And also, as I told you, the 1 kilowatt is costing around 4,000 riyal. And every time, if the project is with a bigger kilowatt hour or a higher size, the cost for each kilowatt will be reduced, but the cost of the project sure will be increased.
Thank you, Engineer Mohammed. I am. Is there no question anymore? Can you let me check? I think there's no question anymore. Unfortunately, yes, Engineer Wael, I don't listen you.
Mike,
Yeah, no.
you don't hear you.
Your voice is not clear.
Your mic is mute.
No, it's not mute, but I think his connection maybe, because
I just want to comment on this question.
Please.
Yes, we cannot have like a fixed payback period, even if we're comparing a region to another region in Saudi Arabia, because we need to calculate the amount of energy. Yes, we could be having, for example, a solar panels that could produce 1 kilowatt, but do we really have the energy of producing? Do we have, for example, the isolation that come from the sun that could produce the 1 kilowatt? What about the temperature effect? So in order to critically evaluate this, you need to evaluate the system. Are you adding batteries or not? Because if you are adding batteries, yes, this will be a more cost to the system, and this will increase the payback period. As well as if we're comparing a commercial or rooftop application to a wind farm, for example, yes, the prices will be, the cost for each tariff will be different, and there will be a huge difference between both tariffs. Sometimes we see some studies comparing these prices, but yes, there are some programs, for example, from the government to encouraging, for example, installing more solar or more rooftop solutions. So there might be some subsidies, and these subsidies should be helping into decreasing the payback period. Here, maybe there, yes, the government is subsidizing the national grid. That's why the comparison with the solar could be at the moment toward the fossil fuel instead of solar energy.
Yes, it's clear. Here, Engineer Wael sent to me an individual that the link for Shamsi to share it with you. He said it's very important, everyone concerned about it, to know about this link. Thank you, Engineer Wael. Maybe because his connection, we cannot hear you. You can open the mic and talk now, Engineer. Same problem. I think by because maybe the connection is poor for you. We are not hearing you. Sorry. Unfortunately, we into the end to our session. I want to send my gratitude and my team gratitude to all the speakers that come today. You took for your time. I know your time is very busy, but you were with us. We are honored to host you with us today, and I want to produce a little bit. Something is it's nothing for you, but that at least what we can do for you. Let me share it. Yes, here is the certificate produced from our branch. Thank you, Mr. Dr. Mohammed, and here for Dr. Wael, Engineer Wael, and here for Engineer Mohammed. Will be sent for you individually. Thank you for all of you. I hope we have more cooperation. That will not be the end, inshallah. The lot of information. It was a very valuable and knowledgeable night. The videos is saved and in the channel. Also be saved in the Twitter. So we are very lucky to save all this information in our accounts. Also, we will inshallah we will make a playlist in our channel, so everyone can see all the sessions that was in our webinar technical series. Thank you, Dr. Mohammed. Thank you, Engineer Wael. Thank you, Engineer Mohammed.
Thank you.
Thank you, Ahmed. I would like really to thank you for this initiative and for all your colleagues. I'm really happy seeing you at this stage of your study, arranging and organizing such an event, hosting all experts in different fields. Thank you very much for you and for your colleagues, and I wish you all the best. And it was a pleasure to be here with you, Engineer Wael and Engineer Mohammed. And I hope we'll be seeing you in another webinar in the soon future.
Actually, we are so lucky to have three of you in one day. It's what if everyone was individually, it will be very valuable. What if three with us in one day? We are so lucky to do it. Right. Thank you to accept our invitation. Thank you, Engineer Mohammed. Anything to say?
Yes, thank you. I would like to thank Dr. Mohammed and Engineer Wael. It's really my pleasure to attend them. I got more benefits also. I'm not only the speaker, also I was an audience. So I got also great information from them. Thank you very much. And I was really happy for participating in such a great event. Thank you for Engineer Ahmed also for such a great arrangement. And I hope, inshallah, in the future also to participate in something like that, inshallah.
Yes, for sure. We will cooperate with all of you again. It's valuable for us. Thank you. Engineer Wael, is your voice clear now, or also the? Yeah, it seems poor connection. Okay, thank you. We can inshallah see you in future, near future, not far future, in our
Inshallah.
university. Of course, when inshallah the pandemic goes on or disappear, we will invite you to do a physical lecture. It's really necessary to our student. Thank you, everyone. Thank you for audience for attendance link. For today, there will be no attendance link. Thank you for the audience too. Thank you for the branches that were participated with us. Branch of King Saud University and the branch of Prince Sultan bin Abdulaziz, and also Prince Mohammed bin Fahad, and also University of Hail. Thank you for all of you, and inshallah see you in next initiative. Bye bye.
Inshallah. Bye.
Thank you.